All right, so let's take a look here at this problem. We've got a parent function, f of x is equal to the absolute value of x, and we want to write a new function that is related to f of x through this series of transformations. So the first transformation says shift the graph of f left 2 units. That's going to affect the x-coordinate. Then reflect the resulting graph across the y-axis. That's going to affect the x-coordinate. Then vertically stretch the resulting graph by a factor of 1/3, and that's going to affect the y-coordinate. So the first two transformations are on x, and then we've got one transformation on y. So the transformations on x are applied before we apply the function. So it's affecting the domain, the inside the parentheses, if we're using this function notation. To go to the left means that we're going to take x and add 2. And then to reflect it across the y-axis means that we're going to have a negative sign in front of that x. So now we move outside of the parentheses. A vertical stretch by a factor of 1/3 means to multiply this by 1/3. So that's how we write this in function notation. But to write it with this parent function, that's what they want. So I'm going to take 1/3. Now f is not a variable. F is the absolute value function. This is telling us to take the absolute value of whatever's between the parentheses. Here it's negative x plus 2. So that's our answer. 1/3 times the absolute value of negative x plus 2. So I hope that helped. Oh, wait. I want to prove to you that I believe is the correct answer by doing it on the Desmos graphing calculator. So I keyed it in ahead of time. The absolute value function, our parent function, looks like a V with its vertex at the origin. Our first transformation of shifting the graph to the left 2 units is actually x plus 2. So you can see there that the Desmos graphing calculator understands function notation, and it knows to shift that to the left 2 units. Then this negative sign is going to reflect this across the y-axis. All of these x-coordinates are going to change sign. So this x is negative 2, and it's going to change sign to positive 2. So that vertex is going to flip across here, across the y-axis, and be there at 2, 0. So let's take away the parent function, and then boom, we flip that across the y-axis, and then this 1/3 is going to vertically shrink the graph towards the x-axis. So something like a height of 2 will now have a height of 2/3. It's gonna be a vertical shrink towards this x-axis, and there you see it. So it looks like the absolute value function is opening wider than what it originally did, and I know that those 3 transformations I know are using my function notation was correct, because here I've keyed in just the function, my final answer, and it's the same as if I built it through these 3 transformations. You can see there's the blue line, and there's the purple. So I hope that helps, and I'll talk to you later. Bye.